Hi, I'm Yu Chao Chen.
I'm Zhongyou Wang.
I'm Zhiting Chen, and we are
Team 8.
Woo! Okay, and now we're recording our Lab4 for our implementation of the mini ideas on NetFPGA. So, first, we can first look at our source file in our lab folder. So first, we can first look at our what kind of files are in our include. So we put our project.xml and our IDS.xml into our include file. And in our source file, basically we include all of our design.v file and also include the IP core, which is that brain we created in Xilinx ISE, so that our design can catch our module in source file. And the last part is SW. Yeah. And we put the IDS reg here. So the next step, we get into scene and do make file. And we make for like 15 to 20 minutes. And then we got our bit file here, which is here. It's called nf2 top pair.bit. And then we use the scp command to upload our IDS reg and our nf2 top pair.bit to our NetFPGA node so that we can download it in our Ubuntu. So next, let's look at our Ubuntu. Let me close all of the nodes terminal here first. So here we start from the host terminal. We type in our group FPGA board number and also the password of it. And then we can get the connection to our NetFPGA board. And so first step, we try to ping each node on our node 3. 结果一下 like this, like this, okay, like this, to this is our node. Okay, so that we can make sure that we can connect between nodes on the NetFPGA board. And the next step is to download the bit file that we just uploaded from our Fedora. So we use the command nf download and type in our file name of our bit file and enter. Then type in rkd and okay, And next step, we need to make our IDS reg executable. So we use the command chmod plus x IDS reg. Like this. Then we can use all of the commands in our IDS reg to do multiple functions like setting up our target patterns, resets, and also use the match command. So first we need to set up our pattern that we want to detect in our IDS. We use the IDS reg pattern, then type in the message that we want to detect. And in this case, we type in get message as a attack message that we want to drop. So press enter so that we can set up. Next we use the reset command to make sure that all of the register in our NetFPGA are reset to 0. And now we can check that if all of our register are reset to 0, like here. So we can see that our matches register are pattern high, pattern low, and command register are all set to 0. And next we can start our main test by setting up one of our nodes into server using IDP like this, and make a attack file in another node, like doing this. So in this command, we store a bad packet.txt, which written get into it. So next, we can send this bad packet.txt using this command to our server, which is node 0 now. So we send our bad packet right here. So now our node 0 have already received our bad packet, and it's supposed to drop the bad packet. So now we can check if our hardware detects the bad packet and increase our match counter into 1. So here we type in OREX to see all of the register results here. So we can find that our matches register has already been increased by 1 here. So it means that our simulation, our synthesis, and what we have done on this NetFPGA is perfect, because that we successfully detect the bad packet. Yeah, and that's it. Thank you.